Good morning, this is Tehmeena Khan, TK, and this is the third video in a series of probability, and this video will have 4 challenging questions which I have picked up from New Mathematics Syllabus D. And here is the address of Blogspot. If you go to that, you can see the link of the other videos and it will facilitate you to find them easily and quickly. And all these concepts we have covered in the previous videos. So now let's go to the questions straight away. Okay, so the question is, on any day the probability that I will miss my bus is 1/7. Find the probability that I will catch my bus on a particular day. So if you have seen the previous 2 videos, or if you have any earlier knowledge, so what will you do? You have 1 second. Yes. Okay, so basically there are 2 possibilities: you catch the bus or you miss the bus. So if the bus is 1/7, it means the probability of catch the bus is 1 minus 1/7. Very good. So it is 6/7. So second question, I have started with simple example. I have written challenging, but the other 3 are challenging. This one is little simple to give confidence to students that they can solve questions from the concept they have learned in the earlier 2 videos. I'll miss my bus on 2 particular consecutive days. So we will look at the diagram, tree diagram also, to understand it for our own understanding. But suppose if it is not, like you don't want to draw it, then what will you do? Because both days you have missed the bus. So what does it mean? It means first day you miss, probability is 1/7. Second day you miss, probability is 1/7. So basically you will multiply 1/7 into 1/7. It means probability of miss. First day, second day, both days you have missed. So it is 1/49, right? So let's see or try to understand this with the tree diagram as well. So question was saying that on 2 particular consecutive days you have missed the bus. So this is representing first day. First day either you will miss or you will catch. And I told you earlier that the sum of the probability of the experiment should be equal to 1. So if you add 1/7 and 6/7, it will be 1. Now next day, this is an independent case because next day probability will remain same. You will miss 1/7, you will catch 6/7. Similarly, if you are catching first day, next day you may miss or you may catch. So this is the probability along the branches, and the outcomes are miss, catch, miss, catch. So if I want to see the probability that I miss the bus both days, I'll multiply like this. If I want to see that I've catch both the days, I'll multiply like this. Right? So now the next question is, so the third question is, I will miss my bus on just one of the 2 particular consecutive days. So it means on one day you are missing, the other day you can catch it. So probability is first day miss, second day catch. So let me write here first and second, first day and second day. So now you will add up both the condition, first day miss, second day catch, or first day catch, second day miss. So from the tree diagram, you can see first day miss is 1/7, second day catch is 6/7. Similarly, first day catch is 6/7 and miss is 1/7. After that, I'm just calculating. I can show you on the tree diagram also. So here is the probability: first day miss, second day catch. So we are adding this, multiplying this and writing here first day catch, second day miss, because question was saying out of 2 consecutive days you are missing bus only on one day. So he's talking about these two cases because one day you are missing. So you multiply and then the results you will get, add them up. Okay, so the last question, last part of the same question is, I will catch my bus on 3 particular consecutive days. Now I drew the tree diagram only for 2 days. So what is the meaning of this question? That first day you are catching it, second day you are catching it, and third day also you are catching it. So what is the probability of catching? Do you remember? Yes, very good. It was 6/7. It means all 3 days it will be 6/7 and you will multiply it. So if you want to draw the tree diagram, please do it yourself and let's see you can do it or not. Do you get the same answer? So this is catching the bus on all 3 consecutive days. Now let's see this example, and why I have put up this question here, because the wording of this question is quite confusing for a student. In my experience, I have hardly seen any student doing this question correctly, though they have clear concept, but still the wording of this question confuses them. So let's see. I will explain the wording later, but first of all I'll give you a chance to understand and then we will see. Suppose I had to find 2 light bulbs from a collection of 12, all but 3 of which are working. If I test each one in turn, what is the probability that I would find 2 working bulbs among the first 3 bulbs tested? So if I ask you, or if you just tell yourself, okay, what did you understand out of this? So from here, collection of 12, all but 3 of which are working. This means there are 12 bulbs, all are working okay, but not 3. So how many are good bulbs, working condition? 9, and 3 are not working. This is number 1 thing. Number 2, the question is saying that you have to find out the probability that 2 working bulbs among the first 3. So you will consider all 3 cases and then you will see 2 out of 3 are working. So your case will be probability of working, not working. By the way, this dash means you are negating what you are talking about here. So it is not basically working, not working, working, or not working, working and working. Why I'm taking 3? Because question is saying first 3 bulbs you are testing and out of those 3, 2 are working bulb. This is the condition of the question. So that's why I'm writing all the possibilities. In a while I'll show you through tree diagram also that how I'm getting it. Now this, what do you think? This is a case of dependent or independent? You think first of all, then I will tell you. Yes, it is dependent. Reason is when you will pick up one bulb and you will see it is working or not working, you will not put it back in the box, right? Because otherwise it will mix up again and you are looking for 2 working bulbs basically. So that's why the total number of bulb in the box will reduce. So this is a dependent case. Let's see a tree diagram and then we will come back here and answer the question. Okay, so here is a tree diagram. This is a complete tree diagram here. But if I take it from the distance, it will become very small. So let me explain half part of it and then you will understand how we are calculating. Okay, so first time when you are drawing, it is working or not working. So out of 12, we know 9 are in good condition, 3 are not. So this is how we are writing the probability here. And I'm repeating, the sum of this probability should be 1. So if question doesn't give you this, you can get this yourself by subtracting it from 1. Okay, so coming back. Second time you are drawing. Now the first one was working bulb. The second time definitely the denominator will reduce, but numerator will reduce or not, it depends what was drawn first time. If the first time it was working bulb, so now in the bag or in the box there are 8 working because 1 is out. So 9 minus 1 is 8 working bulbs, and of course 1 has gone, so 12 minus 1 is 11. Now second time, this is I'm still talking about second time draw. So if the first time it was working, second time it is not working because you have taken out only one working bulb, so 3 non-working bulbs are still in the bag. So the probability will be 3 out of 11. I hope it is making sense to you. Or first time if it is not working, then definitely second time denominator will reduce because one bulb has gone out, but numerator will change or not, it depends on it. Because I'm taking out non-working bulb, so it means 9 working bulbs are still in the box. So that's why it is 9 over 11. And if this is not working first time, so now one non-working is out, so there are remaining 2 bulbs which are not working. So that's why it is 2 over 11. Now the third time draw, I'll just explain one case in detail so that you can or you will be able to understand the rest yourself. Now the first time working, 1 is gone, so now there are 11. Second time working is gone, so now there are only 10 bulbs. That's why denominator is 10, right? So now because both time working bulb has gone out, it means out of 9 working bulbs, 2 are subtracting. We will subtract 2. So 9 minus 2 is 7. So that's why we have here 7 over 10. Whereas here, one working is out, second working is out. It means non-working were 3 initially, they are still there in the bag. So that's why it is 3 upon 10. Because 2 are out, so total were 12. The 12 minus 2 is 10. So this is how we are getting probabilities on the branches. And then I'm just writing like this: working, 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 like this. Working, working, not working. Working, not working, working. So this is how I have completed the tree diagram. I have not written down the probability in front of it. That depends on the question. If I need to write it down, I will write down in the answer. Then I will know at least which branches I have to multiply. So let's go back to the question. So question was saying find the probability that 2 working bulbs among the first 3 bulbs tested. So these were the cases: 2 working, 2 working, 2 working. I got it from the tree diagram. And then along the branches, these were the probabilities written. So I am writing down here the probabilities. For example, if I show you the first case, working, not working, and working, tick, tick, tick. It is here, working, not working, and working. So it is this branch, you can notice. So it is 9 over 12, 3 over 11, 8 over 10. So I'm multiplying these probabilities to get answer of these 2 working bulb. So this is how I have filled up all the probabilities along the branches. I am multiplying and then plus sign, because I'm saying this or this case or this case. In all 3 cases, I will have 2 working and 1 not working. Now let's see the next question. Like I said, the wording is confusing. So again, it is from the same question. Question was saying, what is the probability that I would find 2 working bulbs when 3 bulbs have been tested but not before? So it simply means that you have to test all 3 and then you have to see that 2 are working. So now in that case, only these 2 cases will be considered. I cannot consider this third case, because if this will happen, I will not test the third case, right? So question was saying not before. So until you test 3 bulbs, you can't say that 2 are working. So that's why we are talking about only these 2 cases and writing the probabilities from the branch and then adding them up. So this is how this question is completed, and let's see the third example now. Okay, so the third example is, now you see the questions of probability are usually so long that students basically start panicking when they look at the question's length. So don't worry about it, just jot down the important points when you are writing down or reading the question. So let's read the question. So this is about qualifying for entry test of science stream. A student must have at least 2 distinction in 2 of the 3 subjects, English, Maths and Science. So if the student will get 2 distinction out of these 3 subjects, he will be able to enter in the science stream. This is the rule of the school. So the probability that John get a distinction in English, Maths and Science is 5/7, 3/4 and 5/6 respectively. So before I move on, let me just ask one thing. If I ask you, what is the probability that John will not get a distinction in Maths? What will you say? This is the probability that he will get a distinction. So remember, yes, it's a complementary case. So just minus it from 1. So it will be 1/4. The probability that he will not get a distinction in Maths is 1/4. The probability that he will not get a distinction in English is 2/7. Because 1 minus this is 2/7. Similarly, the probability that he will not get a distinction in Science is absolutely 1/6. So now we know now what is the probability that he will get a distinction or he will not get a distinction. So if you want to write it down for yourself, you can. Okay, the question is saying the John will not be able to get any distinction. So it means he is not getting distinction in English, Maths and Science. So I have just explained to you. So you'll multiply the probabilities and you will get the probability that he will not get distinction and he will not enter in the science stream program. Next question is that he will get exactly 1 distinction. So now you have to consider all 3 cases. So first is getting distinction in English but not in Maths and Science, and accordingly you will write their probabilities. Second is he is getting distinction in Maths but not in English and Science, and you're writing down these probabilities. So I told you earlier that you can put down on the side of the page all these probabilities so that you do not make mistake, because in the question the probability of distinction was given, not distinction you have to find out yourself, which you have found by subtracting from 1. Anyway, coming back to it, and now he is getting distinction in Science only, right? Not in English and Maths. So now you have written down probabilities and you are adding them up. So probability that he get distinction only in 1 subject is 1/8, and which is very low. You can see 1/8, it means he is a genius. So not getting is only 1 is very low. Let's see the last question, and that is he will be able to qualify to enter science stream. So now you tell me, what do you think, which probabilities we will calculate? Do you remember what was the criteria to be able to enter the science stream? Yes, at least 2 distinction. Now at least mean he may get distinction in all 3 subjects as well. So now we will consider 4 cases. In 2 subjects he is getting distinction or in all 3. So first talk about Science mein he is not getting, other 2 mein he is getting distinction. Maths he is not getting distinction, English and Science he is getting distinction. Here English he is not getting, so one by one you can take any one first, whatever you like. And because question is saying at least 2 subjects in the question, So I will consider all three also. Here students make mistake. They forget to take all three distinction. They usually just add up these. So please remember, when the question says at least, it means all three is also included. So now you're writing down the probabilities which we have just seen, and then you add it up. So the probability that he will be able to enter in the science extreme program is 145 over 168. So it's a good percentage. He has bright chances. Great. So you have bright chances to get full marks in probability also. Let's see the last question. Students who are not very good in ratios, they find this question difficult. I have tried it number of times in my with my 11 graders, and that also helped me to understand how many of them are good at ratio, because ratios they study in earlier stages in class 7 and 8. So let's see the question. So question is saying there are 24 white marbles, X red marbles, and Y blue marbles in a box. So it means in a box there are 3 colors of marble: white, red, and blue. You only know the number of white marbles. You don't know about X, red, and blue. Anyway, the probability of drawing a red marble is given to you 1 over 5, and blue marble probability is also given 2 over 5. So you know that if you pick up a marble from a bag or from a box, what is the probability of red and blue, which is 1 over 5 and 2 over 5. And you have to find the value of X and Y. X and Y are actual number of marbles in the bag. So what we will do here, if I add up these two probabilities and minus it from 1, I will get the probability of white marbles. Yes or no? Right? So do you know what I will do after that? How it would be helpful for me? Think. Okay. Keep thinking. You have 1, 2, 3 seconds. Okay, so let's see how it will help us. So I'm writing here white marbles are 24, red are X, blue are white number. So I'm adding up the probability of red and blue and subtracting it from 1. 2 over 5. So this is the probability of white marbles. Now do you remember? In probability, the denominator tells you total number of marbles. I mean total number of whatever is in the experiment. And here we are talking about marbles. So marbles are my total number of marbles are my experiment here, right? And 2 is my favorable outcome, and I'm talking about probability of white. So from the total marbles I'm drawing white, and which is 2. But in the question it was saying there are 24 white marbles. So how come this is telling me 2 only? It means it is a simplified form. So what we will do now? So now actually I am getting, after subtracting from 1, 2 out of 5. But what I should have here? 24, because question is saying there are 24 white marbles. So 2 times what is 24? 12. It means I will multiply 5 or denominator also by 12. So what does this explain? This explains that there are 60 total marbles and 24 are white marbles. Now let's come to red marble. Red marble was 1 over 5 in the question it was given. Now I know from here that total marbles are 60. So I'll multiply 5 by 12, because 5 12s are 60, and then I will multiply numerator also by 12. Sorry, I have written 2, it should be 12. Okay, so it is 12 out of 60. So it means red marbles are 12 in the bag. So 12 was my X. Do you remember the probability of blue? It was 2 over 5. So again I will try to make the denominator equal to 60, because I know from here now that total marbles are 60 in the bag. So if I'm multiplying denominator by 12, I will multiply numerator also by 12. So I got 24. It means blue marble are 24 in the box. So now I know that blue are 24, red are 12, and white are also 12, which was given to me. So now let's answer few questions based on these values of x and y, which we have just calculated. So question is saying calculate the probability that 2 marbles drawn in succession without replacement. Now this is again dependent case, because when you are not replacing it, it means the next time total number of marble will be reduced by 1 and then by 1. So right now we are only drawing 2 marbles, so one time we will subtract. So if question is saying find the probability of the same color. So here is the tree diagram I have drawn. I have white, red and blue marbles, right? First time. Probabilities I have written here. Now this is extremely important. Why I have explained it, pay attention please. This is the actual probabilities and these are the simplified forms, which I have written in very light color. Second time when I am drawing a marble, if it is white, and first time also it was white, it means the denominator will be reduced by 1. It is 59. It was 24. So first one white marble has gone. So now of course there are 23 marbles, right? Now some students who write simplified form here, and if they use this to subtract, because it's a dependent case, so what they will write here, 4 in the denominator, because 5 minus 1 is 4 and 2 minus 1 is 1, which is not equals to 23 over 59. So the particular reason why I have taken this example is to emphasize on that if it is a probability tree diagram, please do not write the simplified form of the probability. It is a dependent case, so you have to subtract. From the simplified form you cannot subtract. Here you will not get the right answer. So always use the original probability. So I don't think I need to explain this, but anyway let me explain one more, because I have explained in detail in the previous question. So if the first time it was white, so now second time denominator is reduced by 1, because one white marble is gone. So out of 60 now there are only 59 marbles. But red were 12 and there is still 12 in the bag or in the box. Why? Because only one white marble has gone, so red are untouched and there is still 12. So that's why it is 12 over 59. This is how you will complete your tree diagram, and you are writing the result along. White, 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 red. I did not write probability here. I can multiply and get it easily. So this is how you will complete the tree diagram. And if question is saying find the probability of same color, so it is white, white, red, red, blue, blue. You can like see from here, multiply them like I am doing it here, and then add up the result. So you will get the probability of same color. Similarly, you can answer rest of the question also seeing this tree diagram. With this I will end this video. Thank you very much for watching it, and if it has helped you to learn any concept, then I would like you to press like button and subscribe it, so you will get the indication of my upcoming videos. Thank you very much for watching it, and do go on my blog site to see my other videos. Thank you. Bye bye.